Hey guys, welcome to this quick little video. One of you left a really useful comment which pointed out that actually the grammar that I've written isn't left to right, it's actually right to left. Now, we can sort of explore why this is the case based on how we've written this, right? So, the way this all works is recursive, so this cast expression might actually be a cast expression, or it could be a prefix, or it could just be like a number. It could just trickle all the way down, and that's how this grammar works. So if we write something like 5 times 4 times 2, then with the grammar we've written, we're saying that the expression should be 5, operator, and then a multiplicative expression. So actually, it's done like this, because by the multiplicative expression being on the right, what we're saying is we're taking the result of that whole expression on the right, and then we're multiplying it to the thing on the left, which works exactly like this. And while that isn't too big of an issue, you can imagine situations where that might actually lead to problems. For example, like this. If you have 1 divided by 2 doing integer division, in a lot of languages that will give you 0. And then if you multiply by 0.5, that will still give you 0. But the way we're doing things, you would actually multiply 2 by 0.5 first, and then you would get this, which would become this. And so you get different results depending on which way you're doing. And in math, we're used to going left to right, so it's best to keep that. And while our grammar doesn't necessarily have to reflect the order of operations, I think it's better that it reflects our code and the actual like structure of our language. I just think that makes the most sense. So if we come up here, we're going to have to change all of these, but it should be a pretty quick fix. So instead of doing the thing on the left is the lower one down, so trickling, what we want is the thing on the left to actually be the recursive call to like this previous one. And then we have our OR, and then after we have a bitwise XOR expression. So what this grammar is saying is either we can recursively refer to these OR expressions. So if we have something like this, we can do that many, many times. Or we could simply resolve to a single like XOR expression, which, as I've mentioned before, could be just a number. I think there's a handful of other ways you could write this grammar. Another option is you could change it so that it's more like a bitwise XOR expression, or bitwise XOR expression with a star, and the star means 0 or more times. So this would be essentially the same, but it's not quite the same. The thing here is, this sort of implies that your expression, like this is technically the same grammar, but when I'm going to be constructing my abstract syntax tree for our language, I'm actually not going to be building it like this way, which is why I'd rather reflect the grammar this line. Because this is implying that we're going to have essentially a list of expressions in our node, and that we'll just perform them left to right. But that's not actually what we're going to be doing. We're going to be constructing a recursive tree structure where the left node is going to be a bitwise OR, and the right node is going to be the bitwise XOR, which is why I prefer to write it like this. But if this helps you sort of understand what it would capture, then that's fine as well. Another way you could write this is you don't need the optional brackets. You could say, well, it's like this thing, or I guess if I write it like I've been writing it, or it just resolves simply down to an XOR. And this would be like, if you're doing recursive code, this is like the exit condition, sort of. If that helps you visualize what's happening at all. It will make more sense once we actually construct the tree. But for now, we can just go in here and essentially do that for most of these. They just have to refer to their self on the left, followed by the operator that we want, followed by the thing that it should sort of trickle down to, which is going to be the thing that has higher precedence. And it has higher precedence because we're trickling down to it. It's still sort of hard to, like, I'm not Like, I understand how this works, but I still don't really... I can't really visualize it well based on how I'm describing it, so I hope it will make sense in the future. This is just a shift expression over here. I'd recommend copy-pasting, but I'm just going to do it the long way around, which also gives you guys time to write it, which is hopefully useful, because there's nothing worse than following a tutorial and having to pause and go back all the time. I do prefer slightly slower tutorials. Additive expression, followed by our operators, which are the plus and minus. And then multiplicative expression. The reason that I ran into this problem with the grammar is because I tried to condense it down, but I just did it the wrong way and didn't realize it wasn't the same. This one that I'm writing now is pretty condensed, and I think it's pretty understandable, but I just didn't see it the first time. So now, as you can see with these expressions, if we do something like 5 divided by 2 times 3, on the left is a multiplicative expression, which means it's this expression on the left, and then this thing on the right. So that's exactly what we want. That's how we want our grammar to work. Now, the cast expressions are actually fine. I'm just going to move this down. No real reason, it's just like a style choice. But cast expression is also left to right. But in this case, the reason it looks different is because these are all binary expressions. And by binary expression, I mean that there's two arguments. There's a thing on the left, an operator, and a thing on the right. And so that's why they have to be formatted that way. Whereas a cast expression, even though there is sort of a thing on the right, it's not really a binary expression in the sense that you don't have an expression on the right, you just have a type. And the type is sort of part of the operation, if that makes sense. But this is still an example of a left to right priority thing, because as you can see, if you tried to make this, if you had, I don't know, 5 as an int as a double, something like that, the left thing is a cast expression, and then you cast that. So it will cast as an int first and then as a double, which is as we would expect because we're going left to right. When it comes to the prefix expressions, again, I'll move this down. We actually want these to be right to left, because if we do negative positive 2, or like 3, right? We would expect this to be saying, take the negative of positive 3. We expect this to go right to left. And similarly, this is a unary operator, meaning it only operates on one thing. But because the expression is on the right of the operation, we already have our like implicit right to left priority. Because again, if we have negative positive 2, then we have the prefix operator, which is minus, and then we have a prefix expression on the right. And same thing here. So you'll have to calculate the 2, whatever the primary expression is in this case. Then you have the op, and then you have the op. So that's how that all works. And primary expressions don't matter because they're essentially, you're not doing anything to them. They just are the like fundamental unit. Parentheses we also don't need to worry about, so that should fix that. Hopefully that helps with any confusion that you've had, and hopefully you can modify your custom grammar to sort of make sense as well. Anyway, I hope you guys enjoyed. I'll see you in the next part where we'll actually start working on our Lexer.